So our next chapter in this paper is electrochemistry. So to understand the electrochemistry, you first of all you must know the basic concept of oxidation and reduction. So what is oxidation? Oxidation is simply the loss of electrons, and reduction is the gain of electrons. So you always keep it in mind whenever the word oxidation comes in electrochemistry. You must know that it's just a loss of electrons, and whenever word the reduction came during our discussion, the it means simply means the gain of electron. And oxidation is equal to reducing agent. So reducing agent will undergo oxidation, whereas oxidizing agent will undergo reduction. So these are same things. You will face these words again and again in the electrochemistry, that is oxidation and reduction. So simply if you will write a chemical reaction to represent the oxidation, it means that A is losing the electron. It may lose 2 electron, 3 electron, or 4 electron. If it will lose 1 electron, it will be converted into a unipositive cation. That is, unipositive cation means positive charge on this ion, with uni word means one positive unit charge, and cation word is itself self-explaining, that it's a positively charged ion plus 1 electron. If it forms a atom forms a dipositive or bipositive cation, then there is a loss of 2 electrons. So simply what does oxidation causes? Oxidation causes loss of electron. These 2 electrons are lost, and this A element or A atom converted into a A2 positive cation, or 3 positive cation, 4 positive cation, whatever. And further, oxidation result in the increase in the positive charge. Here there was no charge on this atom, 0 unit charge, whether it was positive or negative. When it is converted into a cation, there is a 2 positive charge. So it resulted in the increase of it result in the formation of positively charged cation, whereas reduction result in the gain of the electron. So suppose that an atom A is gaining electron, it will convert into the anion, that is uninegative anion. When it is gaining 1 electron, when it will gain 2 electron, it will be converted into binegative or dinegative anion. So reduction result in the gain of the electrons, and electrons means basically electron is a negative charge. So it gained the 2 unit negative charge, and it got converted into dinegative anion. Further, reduction result in the formation increase on the negative charge on the atom. So there are two types of processes. One is oxidation and other is the reduction. So always keep in mind what does it oxidation and reduction means whenever these words are discussed somewhere during our this course. So reaction which involve both oxidation and reduction are called redox reaction. So there are generally reactions in which both oxidation as well as reduction takes place. These are called redox reaction. It means both reduction and oxidation are going side by side. So redox reaction, we will explain the examples of redox reaction during our study of the electrochemical cells. Further, it may be noted that oxidation and reduction go hand in hand. That is, when in a particular reaction there will be oxidation, there will also be the reduction. It means when one atom is losing electrons, so these electrons will be gained by some other atom to reduce. So oxidation and reduction go hand by hand. Here I had written A and A, but the oxidizing element will be different, whereas reducing element will be different in the same reaction. So substance cannot lose electron unless another substance which can accept electron is also present along with. In other words, oxidation can take place only when the reduction is taking place simultaneously. A simple redox reaction is explained as given as zinc and copper sulfate reaction. Zinc copper sulfate reaction. In this reaction, zinc solid reacts with the aqueous solution of copper sulfate. We have to write in there, we have to write their standard states in the subscript, in brackets in the subscript. Zinc will be converted into zinc sulfate aqueous, whereas copper will be converted into copper solid. So practically, whenever you will see this reaction in a beaker, when you will take a aqueous solution of copper sulfate and dip a rod of zinc in it, after some time you will see that this is a aqueous solution of copper sulfate, whereas this is a rod of zinc. Whenever after some time you will see that in this container, same container, zinc rod will get like corroded. It will lose some of its amount, some of its volume or mass, and in this solution of copper sulfate there will be formation of some solid granules. These granules will be of, what is this reaction? So originally there was zinc solid, this zinc solid, and after some times when we dip this zinc solid rod in the aqueous solution of this copper sulfate, after some time there was a reaction that zinc got converted into zinc sulfate, that is zinc 2 positive, and there is a formation of copper, this copper solid. So when a strip of zinc metal is dipped in the solution of copper sulfate, it is found that the blue color of solution slowly fades away and the solution becomes warm. The reaction taking place, this reaction takes place, that zinc solid converts into the zinc sulfate and copper sulfate aqueous converts into the copper solid. So the first point in this reaction is the zinc strip starts dissolving. This zinc strip starts dissolving due to the formation of zinc 2 positive ions in the solution. This is due to the oxidation of zinc metal to zinc ions, which can be written as zinc. These steps of this reaction can be written as zinc solid converted into zinc 2 positive with the loss of 2 electrons. So it means that this is the basically reaction of oxidation. Zinc lost 2 electrons, so it is the first step, and in simultaneous the copper starts precipitating this copper sulfate. Basically this copper sulfate is basically, what is this? This is copper 2 positive plus sulfate di-negative. So this copper 2 positive from copper sulfate gains 2 electron and converts into copper solid. So this is the second step of the reaction. So this indicates that change in the color of the solution indicates that copper sulfate got disappeared, because copper sulfate is originally of blue color and this solution becomes colorless, as I told you. Thus in this experiment zinc is getting oxidized while copper is getting reduced, so it is a redox reaction. The reaction, this first and second reaction are known as half reactions, in which reaction one is an oxidation half reaction, this one, and second reaction is the reduction half reaction. So the overall redox reaction is obtained by adding the two half reaction as zinc solid plus copper 2 positive aqueous gives rise to zinc 2 positive plus copper solid. So in this reaction electrons are directly transferred from zinc metal to copper 2 positive ion, hence it is called direct redox reaction. It is a direct redox reaction because electrons are directly transferred in this solution from zinc rod to the copper. So direct reduction, and further this reaction is exothermic, that is delta H is negative. As I told you earlier, this solution gets warm after a while due to this exothermic reaction, and this exothermic reaction, during this exothermic reaction the heat evolved, that is delta H is negative, and this evolved heat is got distributed in this copper sulfate solution and got distributed in this beaker where copper sulfate and zinc rod both are present. So temperature of this container got increased. So if we try to reverse this reaction, if we place a copper rod in zinc sulfate solution, no reaction takes place, which means that reverse reaction is not possible. In other words, zinc metal get oxidized by copper 2 positive ion, but copper metal cannot be oxidized by zinc 2 positive ion. Further, electrochemical cell. So what is electrochemical cell? So electrochemical cell or galvanic or voltaic cell is a device in which chemical energy of spontaneous redox reaction is converted into the electrical energy. So it means that what are we saying? We are saying that this redox reaction, the energy evolved during this reaction can be converted into electrical energy. So you have seen many more example in your daily life, like cell of wall clock or wall clock or something else is in which chemical energy is converted into the electrical energy. A simple so this reaction also represents the a simple reaction of a electrochemical cell where chemical energy is converted into the electrical energy in an electrochemical cell. And this can be understood with these reaction where zinc rod react with the copper sulfate to give the zinc sulfate and copper. So further we have written this reaction in small steps here, which represents the conversion of chemical energy into the electrical energy. So the two half reaction involved in this redox reaction are oxidation half reaction and reduction half reaction. So these two half cells takes place in two separate beakers. So the further discussion, that diagram of this electrochemical cell and else we will take later on. But till then you must know what is oxidation, reduction and what is redox reaction and what are the results of redox reaction. So this is the result, these are the results of redox reaction, that delta H is negative and where this energy evolved can be used for the further purposes as per the first law of thermodynamics.